Right, folks often like to have just a sequence of steps that they follow every single time. And here you go, here it is. First thing you got to do is classify the system and select the redundant reaction, leaving yourself a stable system, right? A determinate and stable system. Remove that reaction, impose the actual loads, calculate displacements at the locations and directions of the removed redundant reaction, or plural, if you have more than one. Then you get rid of that load and you come along and you reapply redundant reactions in sequence, not all at the same time if you have more than one, right? So reapply them, and then you paste these two back together. That's the compatibility equation. Solve for the unknowns, which are the redundant reactions, and then use equilibrium to find the other reactions, because now you haven't touched the global equations of equilibrium, and now you can use them because you have information about a couple or one or whatever the number of redundant reactions are. Bam, you can find the other reactions. Now you can do shear moment diagrams and deflected shapes and everything else that you might want to do as a part of the design process. That's it, every single time, steps 1 through 7. The bad part about all this is that it involves a lot of calculation of displacements. Not only are those long and difficult, but they require your intervention, right? You can't just computerize them. Well, I got a computer that can do all this. Yeah, sure you can. That's called the stiffness method, right? And that's why the computer method is so much easier. This is a by hand approach. And the thing is if I come along, analyze the system, come up with a beam size, and then I decide to change that, I potentially am changing everything else. And I have to redo everything potentially. Whoa, a lot of work. And that's why the stiffness method was born, was to make a lot of that go faster. So these are the steps every single time. The problem is that they are long, they are tedious, they are difficult at times. And if you change anything in the structure and reaction to what the client, the architect, wants you to change, then you got to redo everything oftentimes. And it's very time consuming and not nearly as good as some of the computer models are that we now have that are based on the stiffness method, as opposed to the flexibility method.